Hello and a very warm welcome to everyone joining today. Thank you for taking time out of your busy schedule to be here. My name is Kevin Cowie, and on behalf of Steel Construction New Zealand, I'm absolutely delighted to host this afternoon's technical session on part 3 of NZS 3404, which covers the durability of steel structures. Now, durability is fundamental to sustainable construction and to achieving resilient, low-maintenance buildings and bridges across New Zealand. With the release of this part 3 of NZS 3404, which has replaced the technical specification, our industry now has much clearer guidance on material performance, corrosion protection, and maintenance expectation. Today, we're going to explore how to apply these requirements correctly to deliver longer-lasting structures while reducing whole-of-life costs and environmental aspects. To walk us through these critical updates, I'm pleased to have a leading industry expert with us today. So our presenter today is Raed Al-Saraf, Director and Asset Integrity Management and Innovation Specialist at Structural Integrity Consultants. I've known Raed for a very long time. He's a highly respected structural and corrosion engineer with over 20 years of experience across New Zealand and internationally. He has extensive practical expertise in assessment and prevention of corrosion for everything from buildings and bridges to stadiums and ports. He is the co-author of the HERA New Zealand Steelwork Corrosion and Coatings Guide, and critically, he's the chair of the Standards Committee responsible for this Standard 3404 Part 3. So there's no one truly better to guide us through these changes. Before I hand over to Raed, just a few housekeeping items. Today's session is being recorded, so upon request, we'll send a link to the replay and slides if so desired. Now, we also have a large number online today, which is great to see. Because we have so many attendees, please drop your questions in the Q&A box as early as possible. And at the end of the session, we'll try to get to a good number of these questions and cover the most common themes. As a brief and important note, the suite of NZS 3404 is being updated. So parts 1 and 2 is actually out for public comment at this stage. And we highly encourage everyone here to review the documents and participate in the consultation process. To support this, we've got a couple of webinars that we've already got planned, and we'll touch on these at the end of the presentation. Without further delay, please join me in welcoming Raed Al-Saraf. Raed, over to you. Thanks.
Thank you, Kevin, for that nice introduction. And thank you and welcome, everyone. I'm quite impressed to see how many of you have taken your lunch break to spend the next hour with me. Greatly appreciate it, and I hope you enjoy it as well. I also note there's a number of AI transcribing. It's just the way the world these days, but like Kevin said, this webinar will be available to viewing later. And if you're interested, a copy of the presentation can also be made available. So updating Standard New Zealand Technical Specification 3404. And look, there's a lot to go through, so I'm just going to get into it. At the moment, we're just in a very fortunate period of time when a number of documents are currently being revised. The key one is the Standard 2312 Part 1. I'm actually on that standard committee as well. And we are not far off from finishing that document and to be going out to public comment soon. Protective coating for steel bridges and the TA document, another document I've co-authored, that's also under review. And of course, the document we're here to talk about today, Standard New Zealand Technical Specification 3404. So with that, we're happy to, you're probably now aware that it is out and there's been quite a few changes. So the original document was first published in 2018. It was cited in the building code as as a means of an acceptable solution in 2018. And we're happy to advise that it's been elevated to a full standard as NZS 3404 Part 3. And as Kevin said, Part 1 and 2 are currently out for public comment, and there's more about that later on. We held the first committee meeting to update this document back in 22nd of July, 2025. Public comments closed 20th of March this year, and it was released just over a year later. I was quite impressed. You kind of forget when you're in the midst of it, updating and working on these things, but a lot of work went through, and I'm quite pleased to see that it is out now. And we did receive 118 comments, which I was told is a good number, as in we got enough to show that people actually read and gave us good feedback, but just under to show that we made a big mistake. So it was just the right number of comments, apparently. I'd like to acknowledge the committee members. Here they are on the screen. There's quite a few of them, and as you can see, there's a cross-section of the industry, from asset owners, corrosion specialists, and industry representatives. Also wish to recognize and acknowledge Mike Ryburn of MB and Willie Mandino of WSP. So what's the scope? So now we're going to go through key changes, revisions, updates that I would like everyone to be aware of. So what is the scope of this document? It does set out the primary and supplementary corrosion protection systems and technical requirements that are necessary to provide the required level of durability to steel structures and their components as defined in NZS 3404 Part 1 in the New Zealand environment. And like I said, it is showing you a pathway to demonstrate compliance with the acceptable solution as well as the verification method. So pretty much it's all there. So what are the primary corrosion protection systems? So paint coatings, which are 2312 Part 1 and Appendix A. In the document, there are some additional paint systems that we've added from the previous one. Galvanized coatings, so whether it's hot dip, duplex galv, continuous galv, or fasteners, that's what it covers as well. And thermal and metal spray coatings, including weathering seal. And of course, and you can see it's in addition to the additional references that I refer to. Supplementary systems that are also covered in the standard are thermoplastic powder coatings, thermoset powder coatings, such as fusion bonded epoxies. That is, for some of you, well, for quite a few years, fusion bonded epoxy, that my recollection, the last 20, 30 years, was not offered in New Zealand, but the last couple of years it's back in the country, and that's the type of system we use, for example, in pipelines, and you can also use it for rock anchors, for example. So it's good to see that type of protection back available in New Zealand. Barrier systems, a lot of you are probably familiar with petrolatum, the old Denso tape, but there's also the new viscoelastic type of tapes and polyethylene as well. So barrier tape systems are also included. And some of them may be familiar with plastic caps to be used to provide additional protection for bolts and nuts. And there are other protection systems used on fasteners, which we'll cover in a little bit. So the next key thing, what it does not apply to, and the reason, and one of them is steel reinforcement in concrete. Over the past number of years, I've seen people try to justify things to do with reinforcement which are not really applicable to the standard. So we now specifically exclude steel reinforcement. So please do not use this document to justify, let's say, mistakes, to put it mildly, in design, and galvanized wire. So those are the two documents that are not, the standard does not apply. So the other thing, we also clarified different roles. We've added those for what we had before. So coating contractor pretty much is a coating applicator, and their job is to apply the protective coating, do the surface preparation, apply the protective coating, and in accordance with the project specification and the manufacturer's instructions. Oops. And from NZTA point of view and Kiwi Rail, at the moment, only applicators who have a painting contractor certification program accreditation can undertake the work. That's specifically for these two asset owners. Everything else, recommendation is you have, let's say, an ISO 9001 applicator with that type of requirement, but I also understand that SCNZ with the steel fabricator scheme are also developing a different scheme that is currently in development that will also help get the applicators accredited, and then you give you assurance that I won't say they know what they're doing, but at least they have the right systems and processes in place to ensure that everything goes on right. Corrosion specialists. This was there before. We've just explained it a little bit better or clarify a little bit better. And such a person who is competent to advise, specify, prepare, and or review all matters relating to durability design, corrosion, coating related advice, specification, and or reports. Is pretty much someone like me and others in the industry that you can go to when you need advice on anything related to corrosion and durability. Now, that person is not just experienced, they need to be qualified with certain qualifications. So it is one off, not all three. So an AMP corrosion specialist or someone with an AMP protective coating specialist. Now, AMP, for some of you will probably remember the old NACE. NACE has joined with SSPC and formed the Association for Material Protection and Performance. So AMP is the new NACE, I guess you can say. Or someone with the Australasian Corrosion Association technologists, who have either completed the coating selection specification course or hold the current AMP certified coating inspector certification. Now that AMP certified coating inspector certification is the old NACE 2, if you remember those terminology. So such a person have one of those qualifications or that combination. And the key thing here, to get one of those, you need to have at least 10 years experience. So it's not someone who just got in course. To get these, you need at least 10 years experience. So it's experience and qualification. Cool. Okay, an inspector. Now this is going to see soon a big thing. So who are inspectors who can do the work? They are, by experience or qualification, is competent to carry out specific inspection duties, typically stipulated by the asset owner, designer, or specifier, to make sure that the project specification or reference standard is done to the right way and meet the requirements. So the applicator, their inspectors, should have either CBIP, AMP Basin Coating Inspector qualification, which should be old NACE 1, or if you're doing hot dip galv, a ACA hot dip galv certified inspector. If you have engaged an independent third-party coating inspector, same CBIP, but it's the AMP certified coating inspector, which should be old NACE 2, or for galv, the hot dip galv certified inspector. Now, this has happened a lot in the industry, so we felt that we need to put it in here. That's why I also made it in bold. It should be noted that a protective coating supplier, so your paint supplier representative, is not the right person or is excluded from acting as the applicator inspector or the independent coating inspector. For the past number of years, I've seen people where they do job and they said, oh, the paint rep came, he signed it off, it's all good. Well, no, it's not. It's not just someone going out there doing a random check once and that's it. There's a whole process that needs to go through. Again, all that process is listed in 5131. We'll talk about that a little bit more. But just to clarify, your protective coating supplier representative is not the right person to do the job of an applicator inspector or the independent coating inspector. They can go and do their own internal checks and do spot checks or whatever, but they're not fulfilling that role. Okay? So please go out there now and tell people you can't do that. We have clarified now the following flowchart that just tells you how to specify corrosion protection system for both atmospheric and non-atmospheric corrosivity. This was based on the work that was in the HARE report R4133, the New Zealand Steelwork Corrosion and Coating Guide. So we've just tidied it up and made it align for this document here. So if you follow those steps, you should get the answer that you're after. Okay, a key change here. You're probably all familiar with the corrosion maps and table 2 that give you the surface-specific atmospheric corrosivity for external and internal environments. The key change here, hopefully you can see my mouse, is down here, C3. So previously this used to be 5 to 20 kilometers for West Coast and South Coast, South Island, and it was 1 to 5 kilometers. That has been reduced to these numbers, to within 5 and within 1 kilometer, and what that means is for external exposed, it is C3, external sheltered, which is sheltered as in non-rainwash surfaces underneath of an awning or underneath of a bridge, for example, that is C4. So that the key difference here is we've reduced those distances. Now, others didn't reduce them for the fun of reducing. This was based on a multi-year study done by brands that we can then justify that change. So what that also means is what happened in those, whoops, jump one. So again, so for the distance of 5 kilometers to 20 or 1 to 5 for external exposed C3, external sheltered is also C3, while before that was C4. And what that meant was the more corrosive environment governed in the past, and you would have had to go like to a more robust system. This allows us to go back to a more realistic system, more suitable for that given exposure. So that will save a bit of effort, a bit of money when you specify the different systems that we have. Same thing here with C2. Previously, that was C2 for external exposed, which was low corrosivity, but previously external sheltered was C3, so that's now C2 for both. So again, that gives you the ability to pick a more realistic, optimal corrosion protection system for that particular exposure, and that is a big change from what we had before. Geothermal sources refer to the different clause specifically for geothermal, and you probably have seen in the news recently the work that Zhengwei Li out of Brand did for the Chatham Island. Chatham Island is a part of New Zealand, so it is included here. Someone did mention to us, you haven't included the Stewart Island. It's like, well, because the work hasn't been done yet. So one day soon, maybe the next version of this document, we can finally put the Stewart Island on. But for now, these are the main changes in this particular case. Better clarification on what hidden steelwork, what is considered dry or damp. A lot of people ask that question still. So hidden steelwork that is within fully insulated area behind a thermal break. And if you've been to my presentation in the past, you probably heard me talking about thermal breaks. And thermal breaks is a requirement under the building code clause E2 and 3, if I remember correctly. If you have steelwork behind the thermal break, behind insulation within the building cavity, then you can take that as dry. Now, what is dry is basically inside a fully air-conditioned office or apartment building. Technically speaking, if you're in a dry environment, it is pretty much C1, which means you can leave steel unpainted, and we'll point that out a little bit. If you are on the cold side of the dew point, so there's no thermal breaks, especially like, for example, warehouses, as you can see in the definition in the next line, that is considered to be damp. And as we show with the previous slide on the tables for internal dry or damp, so internal dry is C1, internal damp is C3 at the minimum. All of those definitions, clarification of what they mean, are also given in R4133, which is included as under Note 1. So R4133 goes with the science of what that means. And everything in this document, actually, a lot of this was really designed where a lot of the science is in R4133, which is, if you're a HERA member, you can download it for free as part of your membership. So if you don't have it, go and get it. If you're not a HERA member, go become a member. And then for high humidity corrosive environments not covered in Table 2 or here, then you need to talk a specific durability design required, and that's where you talk to a corrosion specialist, as discussed, the qualification they need to have so you know who to go to. And that includes stuff like car parks, indoor swimming pools, I don't know, fertilizer plants, storage, or CX extreme conditions that are not normal or not people exposed to every day. We have added new coating systems such as epoxy zinc, zinc phosphate, aromatic thermoplastic organic zinc, that's fluoropolymer, and moisture-cured urethane. We've expanded upon those. And probably for those who live in Auckland, you're probably familiar with the Pukiko Bridge, I believe they call it, which was refurbished, the first motorway bridge that was reinstated with fluoropolymer. Hopefully the red still looks nice and red and flash. It's been a few years since I've been there. We have added 50-year coating durability systems to satisfy the 50-year requirement to the building code. So that's all given for C2 to C5 environments. So while before we stopped at 40. And now just remember the paint system that we have, or the corrosion protection system, which does include galv and metal spray, given in our document in 3404 part 3, are not the only systems you can use. There are others, such as those given in the paint standard 2312 part 1, the galv standard part 2, the metal spray part 3, and also now for the first time ISO 12944 part 5. So it's not just what we have here. You can go to other systems, or if you go to a paint supplier or corrosion specialist and they come to you and say, well, you can't consider this system here according to one of these documents, that is okay. So don't limit yourself to what's in 3404 part 3 only. There are other systems you can use as well. Now, in the past we had it, but apparently it was hidden in the notes, wasn't that clear. But now we specifically say under disclosed that steel in C1 do not require additional corrosion protection and may be left unpainted or bare. This is now a clause in the standard that you can use, as long as within the warm side of the dew point, thermal breaks, insulation, all that stuff that you need to comply with. However, if you do require aesthetic finish as desired or temporary protection during construction, then you can use the guidance, the system given in Table 4. They're all there, and it tells you to what exposure it can be exposed to, which is the last column, and how long that may be exposed, left to be in that condition. So the options are there for you to do so. This is really more for the paint supplier. In New Zealand, we're quite fortunate that most of the paint suppliers are already global companies. They have all the required qualifications. Their paint companies are already, accredited and qualified. But if you do have, let's say, a new system, as long as it's been coating system tested to an ILAC accredited lab, and it has one of these. So most of the systems in New Zealand does have APAS, Australian Paint Approval Scheme. Most of them have that. Or NORSOC M501, which is pretty much what you'd consider using in a marine environment, C5CX. And again, for the first time now, we've clarified it, ISO 12944 Part 6 or Part 9. So if you have someone come to you, the paint system that doesn't have one of these, you are okay, in the sense that this paint system has been tested, it's accredited, we know it will perform and conform to these requirements and these standards. Now, why this is important, the other part of it is you probably heard in the past, a lot of paint companies would come to you and say, oh, we've done these tests, and based on a salt spray test results, it's okay. We're specifically saying, no, it's not. We do not accept salt spray test results to ISO 9227 or ASTM B0117. Not accepted. What we have before is what we want, especially the NORSOC and ISO 12944 Part 9. Those are really stringent cyclic testing, cyclic accelerated weathering testing, which are really suited to show that paint system will give you typically, whatever it is, period, 15, 20, 25 years in a C5 marine environment. That's what we want. Now, the other reason, this is for most people, you're probably not going to be exposed to this, but the next part is important. For intermediate coatings, and this is, I understand, is quite a big topic at the moment in the industry, we're talking about the full system. So it's not just the fire intumescent itself have been undergoing a fire test. The full system, which is typically a primer, build coat, an intumescent, or even if it's just an intumescent, the full system must be tested for the given standards here. So AS 1530.4 or NZS BS 47621. And where durability is required, then everything else we have in this standard requirements must be complied with. And again, I gave a presentation quite a few years ago that showed that you can have an intermittent systems, whole system that give you both durability and fire protection. But the most important thing here is if someone comes to you and say you should use this intermittent coatings, but then you're going to use someone else's primer or someone else's top coat, and the whole system was not tested to show that they're compatible and work together, then you shouldn't accept that solution. Go with a full coating system that's been tested. And that's what I was saying here. All components comprising the system shall be compatible and shall have been tested together as a complete system. That's probably another big lesson that you can go out to market now and say. So honestly, if you go to the big paint suppliers, they'll probably come to you with a full system and you will be fine. It's just when you have someone coming with, use this intermediate and we'll just mix and match. It doesn't work that way. And where it is sourced from multiple suppliers, they just have to show that the test has been done. That's it. That's all you need to ask them. Like, okay, can you show me the test has been done? If they have, then it's fine. But that's what you need to go for. Other paint systems we've also discussed, just referencing here, you don't have to read this. So powder coatings is now there with the references. Proprietary roofing products, so you've probably seen New Zealand Steel or New Zealand Metal Roofing Manufacturers requirements against the proprietary system, so follow their recommendations. And fasteners, so it's not just gal fasteners. So if you're familiar with 8.8, property class 8.8 bolts, they always come gal, that's fine. But there's also other types of corrosion protection systems for fasteners, from thermal diffusion coated fasteners, flake coated fasteners, and weathering steel. You can use unpainted black bolts. Just be aware that once they go in, they need to be blasted unpainted, and all the requirements as you do for painting steel applies. So again, it's just clarifying here, there's not just gal bolts, there are other systems, and these are the ones that need to, what the standard they need to comply with for you to use them and specify them. Over the years, there's always this conversation about aesthetics and top coats. So because we have expected time to first major maintenance, which if you look at a system is when the coatings start breaking down and you have red rust, which is fine. That's why we have the 25 years, the 40 years, and 50 and so forth. If aesthetics is important, then the color fade, resistance, and gloss retention of that top coat is important here. And it is less than the expected time to first major maintenance. So just to clarify that, we've added a new clause, 226, which gives you a bit of an idea of what the typical life or period where that top coat needs to be refreshed for a C3 or under environment. So acrylics, 10 to 15 years, moisture-cured urethane, 10 to 15, polyurethanes and polysiloxanes, 10 to 15, fluoropolymers is 15 to 20. So what that now tells you is if you selected a system, you can go back to the client and say, as a system, let's say a POR5 is a common system in a C3 environment, that will give you 25 plus years time to first major maintenance. But you can say, Mr. Client, Mrs. Client, what that means also in year 10 and 15, you probably have to refresh the top coat. It is really, especially when you have primary colors, unfortunately, the red, blues, and yellows, they just fade in our UV, high UV in our sun. So that just gives you a bit of understanding, both to educate the client and yourself on, okay, if I pick that system, I just need to let them know that I need to refresh it. Now, that does not mean you need to take everything off. In most cases, if you get in the right time, it's probably a wash. Some system you need to abrade a little bit. You can put it straight on, or you may use a tie coat, but you're not blasting everything off. Or it's a much more, I guess, we can call minor maintenance when you refresh the top coat. For a C4 or higher environment, what the expected time to first maintenance applies. We just go with that. So this is more for a C3 and under. And always consult with the paint supplier for guidance on achieving the optimal aesthetic requirements. Hopefully you're all familiar with this equation. It's basically, it gives you an idea of if you have a certain number of V that the paint system give you, and then it breaks down at a certain point, and then the steel itself starts rusting. It is assuming general corrosion, not pitting or so forth, which is a different problem, and we cover some of those in a little bit. The key change here is previously the steel thickness for steel located atmospheric conditions was 8 millimeters. That's now been reduced to greater than 5. And what that means now, all hot roll sections can follow and use this equation. So that's the major change here. We've just clarified how low you can go. Well, before it was 8, and a lot of people like, hold on, but I got this hot roll section. It's like, oh yeah, that's fair enough. So that's been clarified now. Next up is a brand new equation. assessing the remaining expected life of zinc, so mainly for hot dip galv and metal spray. We did mention here aromatic thermoplastic copolymer organic zinc, which is a big word. It's made as a form of a zinc-rich coating, and that in this particular case, you need to talk to the supplier. But if we're talking hot dip galvanizing, zinc metal spray, you can estimate what is the remaining life of the zinc in years for the given environment and system. And it just gives you an ability, and that's for both atmospheric and non-atmospheric, and non-atmospheric for galv only, which then refers to section 3, which relates to non-atmospheric corrosion. But this now gives you the idea of, okay, I got some galv, I don't know how long it will last, or this will give you an idea, and you can estimate that. So that's new. We've tidied up the non-corrosive, non-atmospheric corrosion exposure conditions for soil. We've simplified it. A lot of the old notes, this used to be a really big table with lots of notes, that's been incorporated into the commentary and clarified what we're mainly talking about. Driven steel piles or buried steel work is referencing the appropriate standards. My only request for everyone is if you are dealing with piles or buried steel work, when you talk to your geotech, preferably before they go out to site, tell them, can you please at least do a soil pH, chloride testing, or resistivity? One of these tests, not all of them. And I was told the soil pH is the cheapest one, the simplest one to do, because at the moment, nobody does that. Geotech do not do that. It's very common for people to come to me later and say, I need to, how long will this steel last in the soil? And the first thing I say is, what's your pH or chloride or resistivity? And they're like, we don't know. And the geotech already been there and the report has been issued and we need this tomorrow. It's like, well, now we start guessing. It is a very simple test. Please, please tell your geotechs, do the soil pH, because it's not a standard practice at the moment. Because once they give you that, they do their testing, and you now know what your soil is for your pile, let's say, and what type of corrosivity it is, you can then follow through with what's given in that section 3 of the standard, and it will guide you through what is the corrosion rate for that given corrosive, mild, moderate, or severe environment. And then it'll also give you guidance on how to protect it. So that's another big lesson, please, soil pH. Go with that. We've also tidied this up a bit on the different systems that you can use in these type of non-atmospheric environments, whether it's soils, marine, and so forth, and expected lives. We have since found out that all 2312 did not have that information. This was based on what was given in the ISO standard. To be fair, we have down-rated it. So there is potential, as we see here in comment note D, that a longer durability period may be achieved in service, but we have down-rated it until we have better information on the performance of these systems on the different types of non-atmospheric environments. So there's a opportunity we're bidding on. Fingers crossed that we get the funding, and then we can start doing some research on this. But the information is there to guide you and help you. And again, always feel free to contact a corrosion specialist or the coating supplier when you need more help. Section 4 has been fully rewritten. A massive focus on quality, ensuring coating performance. All the appropriate references to 5131 with expanded commentary as well. And clauses that cover surface preparation and application of corrosion protection system, heavily based on 5131, the inspection of coatings, and inaccessible surfaces. We've also added detailing for durability. A lot of those used to be in R4 Hair Report R4133. Again, all the science is there. We didn't replicate everything. We've just taken that particular details to help you. So all the guidance on durability is given in at the moment. There's other references you can go to. So 2312, Part 1, 2, and 3. ISO 12944, Part 3. Brands, designing for maintenance, and Hair Report R4133. So all the science is in the last two. The first two are standards with some guidance on how you detail. But in addition to that, we've added here now. So for example, if you need something to protect you against dissimilar metal corrosion, if you're mixing stainless steel bolts with mild steel, here is an example of how you can protect and separate them. These, you can buy these, they're called top hat washers. They usually come in 2 pieces for each end. They're either plastic or neoprene, so or you put separation layers. And again, all the guidance is there. It's actually always been there in R4133, pretty much from 2005 and in 2011 and 2020 when we last updated it. We've just added here just to make it clear for everyone. Another typical example, hopefully you're all familiar with this now, is how to protect base plates. And you probably heard about the 150 microns of non-conductive paint, which is an epoxy, for example. Why? Because base plates do corrode. And this is, again, I've been talking about this for quite a few years. This is an example on the Cambridge bypass quite a few years ago, brand new galvanized Texas rail barrier, and within 2 years they were corroding heavily. And it was actually not the steel fault or the galvanizer's fault. It was just that the dry pack mortar wasn't installed correctly. There were major voids, water got in, and we just created a beautiful acidic environment that ate through the zinc, which is why putting a little bit of extra paint is very cheap insurance in that case. That costs a lot of money to fix. Same thing here with ground planted, whether into concrete or soil. Just add another extra layer of paint, and it needs to be 50 millimeters above, 100 mils below. In this case, 350 microns of paint. And this is what you're protecting against. You've probably seen it for light poles like this one, ground planted. They didn't have this additional protection, and this is what happened. They start corroding. It's a very, we call it ring bark corrosion. Again, all of this wasn't previously available in R4133. Now it's just given here in the standards for you to simply say, I got the situation, this is what I want, here's my answer. Maintenance of structural steel, just a bit of clarification. Honestly, a lot of this is, I guess you can say common sense, but it's actually now given. So always allow for future access inspection, future access for inspection and maintenance. We don't do this anymore. This is back in the good old days. To do something like this guy's doing on the Auckland Harbour Bridge, there's a road closure and everything. But back in the good old days, that was normal. Otherwise, if you have a situation where your component or structure is in a really difficult location, access inspection and maintenance is you have to be pretty much impossible. Then you need to specify a corrosion protection system that can meet the project requirements without maintenance. Or you incorporate the corrosion allowance into the structural design as discussed earlier on the equation section clause 2.3. But also they recommend that you consider developing a corrosion management plan and maintenance specification. So it's not just a question of I'm going to put a paint system and it will last X amount of years with nothing. No, you need to start thinking. You need to treat the corrosion protection system as an asset by itself. It really saves a lot of money in the long run when you do it right at the design stage. We're not far off. There's a new Appendix B, which covers a sampling plan for quality level 2, PC2 to 5131. There had been a few situations in the last few years where people are like, well, how many samples or how many testing or sample spots do I take? So we've clarified that to help mainly the inspector in this case. There's a whole new section on sustainability. I'm not going to go through this now, but it's pretty much, I think, the first time in a lot of other standards that something relating to sustainability of corrosion protection system was included. And it talks about what's the definition of sustainability, explanation of the carbon modules, the use of environmental product declaration, EPDs, use of life cycle costs, not life cycle, carbon analysis as well, in addition to life cycle costing, and key consideration for practitioners about how to design an optimal low-carbon sustainable solution. Now, the good news is NZS 3404 is available for free. It's a free download. Go download it. Please download it, have a look at it. I have, while I'm going through this presentation, I found a few errors, typos, so we'll pick those up and tidy them up later, the next version. But it is a free download. And yes, please feel free to download it and have a look, and hopefully it can help you, which is the whole purpose of this document. Kevin. There, Kevin.
Thank you, Ray. Just before we go on to the questions, so for those who haven't asked your questions, now is the opportunity. And just also, if you feel like there's an important question that should be answered, please enter your votes in. But these are just upcoming webinars that are going to be touching on the public comment for the Steel Structure Standard Parts 1 and 2. So the first webinar there is going to be covering primarily Section 2, which is the materials. And it's quite a number of changes in that area. So it'll be an opportunity for you to go into depth into that area. Our second webinar there is a couple of days later, where we'll be touching on a lot of the other sections, excluding fire. So pretty much we'll hit the main changes of the other sections, and we'll also cover the materials part again in a very brief time frame. There is another webinar being planned to cover fire, but we haven't quite got the details for that sorted out, but just keep a lookout for that. Now, just for your information, public comment on parts 1 and 2 does close the 22nd of September, so please do get your comments in by then. So now just going through the questions. I see there's been a number of them.
Yeah, I can see them, Kevin, actually. Do you want me to just, I'll stop sharing just so I can have them in front of me, and I can start from the bottom. A lot of good questions.
Yes.
Okay, hold on. Let's start from the bottom. What do we got? And we got someone saying, do you know if the inspection testing industry have enough people? And then someone actually answered them as well, did they? Oh, God, there's a whole bunch of commentary going on as well. People answering each other. That's great. To my knowledge at the moment, look, yes, they are there. There's a lot of, old NACE 2s, certified coating inspectors, CBIP, and the ACA and galvanized. So yes, they are there. Just need to specify it when you need them for your particular job. So from a specification point of view, NZTA S9 is a model specification we have prepared. It's been out for 2020. That gives you an example of a model spec, which also covers all the quality requirements. To give you as a reference, for example, it also has a model inspection and testing plan. So have a look at that. There's a couple of, okay, let me just, this is how far inland can prevailing wind extend the distance to be considered C4, C5? The corrosion maps are still there in the country. The distances that really need to talk to a metallurgist, and NIWA are great for that. But typically C5, depending on whether West Coast, East Coast, and so forth, is within up to 100 meters to 500 meters, and then it drops to within 1 or 5 kilometers, like we said for maybe getting the numbers wrong now. What we have in Table 2. But it really depends. And sometimes we also recommend, depending on the job and its value, of doing site-specific testing, especially if you're in a borderline situation. We have, more often than not, I found when we do site-specific testing, it's actually not as bad as we think it is. So it is of value, but depending on the particular job. Is there minimum R value for thermal brakes? Clause E, E2 or E3 of the building code, it's all there. Yeah, please have a look at it. It's been around for a while, but I haven't found that a lot of people are actually not aware of it, but it's all there. For warehouses, internal dams to be conserved in certain situation, if the steel is fully accessible, short time to first maintenance. Okay, so for warehouses, internal dams seem to be conserved in certain situations. That it really dependent on where it is, and you're right, it depends on how accessible the steel is and where the openings are. There's also the last couple of years, 2021, the need for ventilation into warehouses. That I think changes the equation a little bit. More work needs to be done. Relating to time to first maintenance. Now, you probably are familiar with the building code. There are 3 periods, 5 years, 15 and 50, which is a function of how easy it is to inspect and maintain, while 50 years is also for structural components that need to comply to provide 50 years. I personally think 5 years is too short, even though, again, specifically in the building code, coatings are listed as a 5-year system. That is a very expensive way of maintaining something. So specifying, it's just a conversation you can have with the client about what is their expectation regarding to maintenance. And I can tell you now, most clients do not expect their steelwork needing to be repainted every 5 years. So while it does say 5, I would say 50. My preference is 25 years, because then by the time you pay, it's actually not that much more cost to go to a 25-year system from 15, and when you need 50, you go to 50. So the whole purpose of internal damp is about condensation. And when you do have condensation occurring, you have steel that is exposed to higher time of wetness, especially if you have complex details where you're going to get water collecting, that's when things go wrong. So yes, every job is different. And that's where that's why your job is to check it out and see where the right system fits the bill. But you need to talk to the client about the expectations as well. Oh, that's a good one. If you stray from C3 as outlined, is that a non-compliant? Probably, yeah. That's why we have it there. It may be deemed to be conservative. But again, don't forget, the other way of dealing with corrosion is also changing the environment itself. So you can treat it with thermal breaks and so forth, or ventilation. That whole ventilation thing is new. A little bit more work is needed to see what the impact. I think if you use ventilation correctly and you can justify that the internal environment is relatively dry, continuously relatively dry, you could make the case using the verification method, alternative solution, to say, hold on, I can go to a lower system, or it's not a C3, it's a C1 because of what I've done with ventilation, for example. So there you go. Table 3, external wall near openings. Does that only apply to sheds or other building type? I would say it's also other building type. It's, again, R4133 got a whole section about how to deal with openings. If you look at that document, there's a whole section there about, let's say, car parks and how to deal with openings there. And it was all based on that earlier, what we have there about, yeah, so it's not just sheds. Is there any guidelines to select first maintenance period? As discussed, building code give you those 5, 15, and 50. There's also the client expectations. Those probably a good starting point, but that's where the maintenance clause of the standard now comes in about. It's not just picking the cheapest solution or with the shortest life. Then there's also the client expectations, and in most cases, picking a more durable solution up front with the longest possible performance will give you the lowest all life and costs. Sorry, not life, or overall costs as well. So have a look at those as well. What we give you is expected time to first major maintenance as given in the standards. So you then need to select what the client wants, or the expected time to first maintenance that they want, and you pick the one that best suits. And honestly, a lot of time it's really down to cost. Is there any guidance available regarding the design or service life of intermittent paint systems? I would say no. That is something probably needs a little bit more work. In theory, if you use, again, let's say POR5 is a common one where we can design that for both aesthetics and durability. If you design it right, apply it right, all that type of carry on for the given application, it should, in theory, give you the expected time to first maintenance of that paint system if there was no fire. And from memory, a lot of that performance of intermescent coatings is really dependent on putting that top coat on to protect the intermescent, especially from water. So there's a bit more to it. That's where you talk to the paint supplier to design a system that complies and give you the expected life. There is the passive fire group. They have a good intermescent coating specification, but you are correct. There is a bit of a disconnect at the moment between durability of intermescent coatings. That's probably something, Kevin, for us to do one day.
Yep.
Yep. Top hat washers, I would say, let's say 3 millimeters, a few millimeters beyond the size of the stainless steel washer. It's all about breaking the, or how about pretension both? Okay. Whew. Okay. Sorry, they're two separate things. Top hat washers. So it's all about, with stainless steel and mild steel, it's an electrochemical reaction. There's a return loop. So you have, let's say, the shank of the stainless in contact with the steel. That is your first connection. And then the return loop is the washer and the head in contact with the steel. So by separating that return loop, you break the connection and there's no galvanic corrosion. So yeah, a couple of millimeters is fine. How about pretension both? Stainless steel typically are not pretensioned. A couple of years ago, the Europeans did this major study, and it's like 500 pages report. Technically, you can, but in New Zealand, we don't pretension stainless both. So it's not a problem in this particular case, as long as you don't pretension them. So steel embedded in concrete above the ground. Yep. Yep, so that I'll discuss in the presentation. So if you are in contact with concrete, the base plate, you have 150 microns of an epoxy, for example, or ground plan to 350 microns, 50 mil above, 100 millimeters below. And again, the reason for that is something called aerial differential. There is more oxygen above ground, so that area is more active. And what it does is start protecting the parts of the steel that are buried. And that relationship doesn't extend the whole post. So again, it's all about breaking that connection and putting that additional paint at that layer breaks that reaction. That's why we do that. I've had situations where, let's say, you have a base plate and they decided to bury it underneath 200 millimeters of concrete. Then in that case, it's like, just paint the whole thing. It's fine. Just easier from an application point of view, ensuring that the whole thing is protected. But if you have a post that goes meters into the ground, it's typically that top part that's needed. When you duplexed coat a hot dip galv steel that does provide required protection, yeah, technically if you go to, I think, a system 4i or 5i or one of those, that it's basically 150 microns. So you can, if you want, just say HTG system 4i from memory, if I'm correct. I may be wrong. And then you'll be fine. Will 3404.3 be cited in the new? Well, hopefully, yeah. I mean, it's in the current one. I don't know why they'll take it out. Have you heard something, Kevin? Are they taking this out?
No, there's a process involved, so it's when the next cycle comes around.
Yep. Hold on. Okay, let me just refresh. God, there's a whole bunch of stuff now. How much time do we have? Not much. Sorry, guys, I'm going to have to skip a few, but like I think Kevin said, we have a plan of collating all these questions, and we'll probably prepare some frequently, give them some responses later. Hold on. This is an interesting one from my friend Reese Rogers. Oh, man, you're heckling me today. Is it wise to place so much reliance on the thermal barrier and water ties for building envelope to protect uncoated steel, particularly in areas that are difficult or impossible to inspect? The consequence of a leak or poor installation in local areas is not huge for a building, but if that leads to invisible structural corrosion, the consequences could be severe. Seems like the cost of a nominal coating on galv layer would be justified to eliminate the risk of a national standard perspective. Yeah, I agree with that. It's the cheap insurance. Put a bit of extra protection. Having said that, again, thermal breaks, water tightness, all that stuff, that is a requirement of the building code. I'm not creating something new here. We need to demonstrate compliance with the code, and there are acceptable solutions of achieving that. And the science behind it is if the steel is warm, you're not going to get condensation, therefore it won't corrode prematurely, have those problems. If it does leak, well, that's now a risk, isn't it? I mean, I cannot control everything. It's really down to correct installation, construction, and so forth. But yeah, if you can justify the cost, you can paint it and put all that on. But there's been many examples where buildings have gone up correctly, have been insulated and put up correctly, and they perform beautifully. There's a lot of examples of black steel buildings, just normal high-rise buildings that are absolutely fine. So, yeah, that's the question bigger than me, Reese. It seemed another one on insulated, uninsulated. I think that whole conversation, Kevin, probably is worthwhile. I'm just looking at these questions for us to go back and maybe have another sit down. There's certain people in people's name, like Andrew Gore. We can sit down with Andrew and others and have a bit of a chat about that and probably develop guidance to suit. Charles Clifton, what about allowing for unpainted steelwork during the construction stage? Is there a surface-specific atmospheric corrosivity level for says 6 months does not need special consideration? Well, we just say you can't leave it unpainted, and it may get a little bit rusty. But as long as you, especially if you're in a C4, C5 environment, you wash it down before the building is closed up, and then it goes behind insulation, lumber breaks, so forth, it is fine. And I think we do have extra words along those lines. But for most cases, people are quite happy to put a paint on or a primer at least, and we gave the options there as well. So it's all there. Any advice on how to accelerated low water corrosion for projects? Yeah, check it. It's a very relatively simple check. We've used a crowd called BioDet in the past. They go and take samples, or the contractor goes and takes samples. There's certain ways of getting the samples, by the way. Fresh, whether it's the water or the soil or whatever, and send it there, and they can check for the presence of bacteria and give you an idea whether there is a risk of accelerated low water corrosion. There's also, if you have any steelwork close by, go check those. So sheet piles are a really good way of checking for that. Having said that, I have now found microbial influence corrosion, accelerated low water corrosion risk pretty much in every single port, and in brackish water and the back of farms behind Poraroa. So it is here. Not as bad as we think it is, but it is a simple check to do. I'm going to take one more because it's nearly time. What are the relative costs of the new coating system? Any added to reduce costs? If you look at R4133, there is a cost comparison between the different paint systems in the HERE document. That should give you an idea. But again, talk to your applicator or coating supplier. But pretty much, if you think about it from a whole of life point of view, a robust long life system, while it may be expensive upfront, typically had the lowest whole of life costs because of reduced amount of maintenance over time. And it's 1 o'clock, and there's a lot of questions.
Thank you, Raid. Yes, certainly we did have a lot of questions. So like we say, we'll go through these and see how we can address them and distribute it to attendees here. But thanks again, everyone, for joining us. And thanks, Raid, for your contribution expertise today. I really appreciate that. And have a good rest of the afternoon, everyone. Bye.
Yep.